Throughout the modern oil age, Exxon Research and Engineering Company has been creating new processes, products, and engineering technologies to keep the wheels of progress turning, meeting society's ever-changing needs in a variety of ways. Since our founding in 1919, we have undergone many changes, but one thing has remained the same: our commitment to providing opportunity and advantage for Exxon's operating affiliates. The tradition for this success began in the 1880s, almost 40 years before a formal research unit was created. In those days, industrial research was conducted on an ad hoc basis and was directed almost exclusively at current problems. It was the infancy of the petroleum industry, and Standard Oil's primary product was kerosene for lamps.
In 1882, Standard Oil set up their first lab at 128 Pearl Street in New York City, and this was run by a F.W. Irvine. 1 year later, however, they set another lab up at 26 Broadway, which was headquarters of Standard Oil, and that was run by George Seibold. Now, George Seibold was a gadgeteer, and his name will always live in the Seibold viscometer and other pieces of test equipment. Both these labs, in fact, were precursors to the product research work, which is done by Products Research Division later. In 1886, they set up a lab out in Whiting, Indiana, under a man named Fresh, and that lab did process research, in other words, refinery-type research, of the kind that is now done at Baton Rouge, Louisiana, for Exxon.
The course of history changed in 1911 when a Supreme Court decision separated John D. Rockefeller's Standard Oil into 34 companies. Standard Oil Company, New Jersey, one of the remaining companies, lost access to key research laboratories and technical networks. In response, new departments were created to service Jersey Standard's needs, including a general engineering department, first of its kind. But it was really the petroleum demands of World War I and the burgeoning demand for automotive fuels that made it clear a strong technological base was essential. Walter Teagle, president of Jersey Standard, addressed the problem.
I have felt more than ever before the need for a thoroughly organized and competent research department under an able executive. Such a department not to be confined to chemical research, but to general research, in connection not only with production and refining of our products, but with the sales end of our business as well.
On September 27, 1919, a formal notice announced the formation of the Development Department of Jersey Standard, located at the Bayway Refinery. With a staff of 26 employees and the support of leading academic consultants, ER&E was on its way. The 1920s, distinguished in many ways, were also a time in which new processes and products were developed to feed the growing appetite of the expanding petroleum market. From that time right up to today, our work has been influenced by the supply and demand outlook for hydrocarbon resources.
In 1927, Frank Howard, who was then head of the research division of what is now the Exxon Corporation, decided that there was a possibility of a critical shortage of petroleum materials in the U.S., and he decided to visit Germany and find out what they were doing in terms of hydrogenating coal. He went to Germany, picked up that technology, decided we should do something with it, and installed German reactors and catalysts in Baton Rouge. To operate that, he needed some people, and he hired 15 professors and students from MIT to start the Baton Rouge laboratories. By the time they arrived, of course, the East Texas oil fields had been discovered, and there was no longer a need to produce synthetic petroleum from coal. So they swung their attention to another great need, that of improving the yields of gasoline and the quality of gasoline-type materials from petroleum by using the German catalytic hydrogenation technology.
The hit-or-miss nature of petroleum processing was evolving into a technical discipline which contributed to and benefited from the emerging field of chemical engineering. Research centered on producing chemical feedstocks, improvements in the yield, the quality, and the flow characteristics of lubricating oils, and fast, efficient, continuous refining processes for transportation fuels. In a creative environment, supported by management, researchers were encouraged to explore uncertain territory. A good example, the discovery of butyl rubber. In 1937, Bill Sparks and Bob Thomas were trying to perfect a motor oil thickener when they accidentally concocted a white rubber-like mass. With further experimenting, the results have gone down in history. The first synthetic rubber. And not a moment too soon. World War II had an urgency of its own. Tanks and tire treads consumed large quantities of synthetic rubber. Lubricants were needed to grease the war machine. And British and American aircraft depended on high-octane aviation fuel. The pressures to commercialize fluid catalytic cracking, a breakthrough process that would satisfy these needs, were tremendous.
The Standard Oil Company of New Jersey was very fortunate in 1938 to have a man of real technical genius, E.V. Murphy, in charge of new developments. We were under great pressure to license a process to make high-grade gasoline. This would have cost us $50 million. Instead, Mr. Murphy wanted to make a better process. Now, this is a tremendous gamble, but fortunately, our parent company was willing to take a chance on investing the millions of dollars to build a commercial unit using a brand new process. Not only that, but our country was willing to depend on this process for a great deal of the war effort.
Fluid catalytic cracking became an area of intensified corporate focus, brought forth with great deliberation and speed. First, the fluid-solids theory developed by Warren K. Lewis from MIT, the father of chemical engineering. Next, the patent for the process transport system. Then, the pilot plant, and finally, commercialization at Exxon's Baton Rouge refinery. Today, cat cracking is the most widely used refining process, producing about half the world's gasoline. The post-war years were times of extraordinary global and domestic growth. Babies were booming, the suburbs were blossoming, and America was learning that it couldn't live without the automobile. New refining and petrochemical processes were being developed at an astounding pace. Fluid coking and hydrocracking to upgrade heavier fractions of crude oils. Power forming to raise the octane of gasoline. Hydrofining to remove impurities such as sulfur from petroleum feedstocks and products. And dill-chill dewaxing to create high-quality finished lubricants and waxes. By 1965, Humble's Baytown Research and Development Department had become part of ER&E.
Those were extraordinary years. Exxon continued to invest heavily in research, and as the breakthroughs came along, why those were immediately translated into new processes and new products. For example, zeolites. I was involved particularly with that development of zeolite catalysts for cat cracking, along with the improved chemistry. At the same time, the chemicals business was expanding into new products and new processes also. For example, there was polypropylene and polyethylene and oxoalcohols. In addition, at the laboratories, we had new improved analytical instruments and computerization of pilot plants. Computerization was actually moving into all phases of the petroleum industry and into all phases of our R&D business also.
Computers change the nature of information work forever. We were able, for the first time, to use computers to handle text. And what a door that opened. We had created internal databases of information. We were able to access, through a computer, external databases of information worldwide. We were able to work with our scientists and engineers and other technical people to bring them resources that they had never had before.
Appreciation for the increasingly important role of fundamental research culminated in the formation of a new pioneering research unit, corporate research, to explore the frontiers of scientific knowledge in areas pertinent to Exxon's business interests.
In corporate research, we've worked on some very exciting research problems. In my laboratory, we were developing the concept of bimetallic clusters as catalysts. The application of these new catalysts made it economically feasible to produce high-octane number gasoline without the addition of tetraethyl lead. It also had the important consequence that catalytic converters could be applied in automobile exhaust systems to decrease the emission of pollutants to the atmosphere. In corporate research, there is an aura of excitement about science. When the science leads to a major commercial application, there's a special feeling of satisfaction which accompanies this excitement. For the industrial scientist or engineer, this is the ultimate reward.
This period also marked the beginning of global expansion, with product labs and engineering offices established in Europe and Canada. Around the world, teams of scientists came forth with groundbreaking products, which ranged from the first synthetic aviation turbo oil in the 1950s to today's award-winning Exxon, a synthetic base stock for motor oils. During this growth period, many major construction projects were also launched, significant design and project management challenges for the engineering group.
Throughout this 25-year period, world around, we were looking at each year 2 major projects. And at any given time within ER&E, there were probably 8 to 12 projects being worked on under some phase of the development through the startup and follow-up. ER&E provided full spectrum of services to the affiliates for these, and that ranged over everything from the planning work, through the design work, through the project management work, and included the startup and troubleshooting afterwards, and that in turn also involved the development divisions within ER&E, because we needed new process developments and new products developments.
This was a period of great expansion, and during this period, Exxon took a giant step which really separated it from the rest of the industry. We decided that we would no longer do detailed engineering and procurement with our own forces. Rather than to do this, we're going to contract these services along with construction. Now, this put us in a leadership position, an overseeing position rather than a doing position. It also gave us an opportunity to concentrate on the management of projects. And we developed very innovative and creative methods of contracting and of managing, which were put into manuals so that our people could use them regardless of where they were in the world. Now, the result was a dramatic improvement in project performance, both from a cost and schedule standpoint. Exxon, of course, benefited from this by their competitive position.
ER&E changed homes several times over the years. When Bayway became overcrowded, the company moved to Linden, and then later expanded to Florham Park and Clinton. In these nurturing environments and throughout the company, the dual ladder for advancement evolved as a permanent part of ER&E's culture.
Well, ER&E created the dual ladder in 1947. It recognizes opportunities for advancement along managerial lines and also opportunities for advancement along technical lines. For the first time, people that were very strong technically were able to concentrate on the technical aspects of their job without jeopardizing their opportunity for advancement within the company. I believe that one of the reasons we're as strong as we are in research and development and in providing technical service for our affiliates is because of the technical ladder.
Throughout the decades, ER&E has provided the technology to help Exxon carry out its steadfast commitment to the safety of its products, the impact of its operations on the community, and the working conditions for its employees. With innovations like energy-efficient refinery designs, more effective lube oils, and cleaner gasolines, ER&E has helped position Exxon as an environmental leader.
ER&E was given the task of trying to anticipate whether unleaded gasoline was going to be the requirement to meet these low emission standards by the mid-70s or so, or whether we could do it with leaded gasoline. We did the work. It proved to us that unleaded gasoline and catalysts were going to be standards for the vehicles. This was very important because it gave them a chance to make unleaded gasoline in advance of the time needed.
ER&E also anticipated the need for carbon canisters, which control evaporative losses from fuel systems, HTA to improve drivability, and lubricants like Uniflow, the industry's first fuel economy motor oil. To protect the environment of surrounding communities, we developed breakthrough technologies like thermal denox and wet gas scrubbers, which remove particulates from flue gases. Throughout the years, Exxon has been taking steps to ensure a safe and healthy working environment. These efforts culminated in the creation of a separate but affiliated organization, Exxon Biomedical Sciences Incorporated, which provides consulting and laboratory services addressing the human and environmental health aspects of Exxon's products and operations. In the 1970s, synthetic fuel research returned to the spotlight. In response to a perceived shortage of crude oil resources, ER&E in Baytown developed the Exxon donor solvent process, which converted coal into liquid products. EDS has since been surpassed by ER&E's proprietary microcat technology, which further reduces the cost of making liquids from coal. In recent years, ER&E has been reshaping itself to fit into the increasingly complex puzzle that represents today's energy business. There are nearly 3,000 people at ER&E and affiliated organizations. The scientists and technicians, the engineers, and all the talented people in supporting roles working together to maintain Exxon's competitive edge. Guided by our business partners, the road to the future is clear. Now more than ever, responsiveness and adaptability are key. We are working harder and harder to get lighter grade petroleum products from lower grade feedstocks with unique processes like flexicoking. And all our efforts are geared toward making a high bottom line impact as we push forward with new products like Phase 4 gasolines and Ultron motor oil, and new technologies like AGC-21, the advanced gas conversion process. Exxon Research and Engineering Company, a company building on the solid foundation of its past, creating technological opportunity and advantage long into the 21st century.